All right, here we are, lesson 2 for functions. Our unit for functions, unit 5. A function that is linear will have a constant rate of change, or slope, and can be distinguished from a nonlinear function in the following representations. So we talked about this last chapter. Linear equations can be written in the form y equals mx plus b. So anytime you see an equation that's in that form, we know it is linear. Keep in mind here, I highlighted at the title, linear line, okay, tells us straight line. A linear table, okay, constant rate of change, which means that as the x number changes, okay, look how the x number is adding 3 every time. It's consistent, okay. The y number is adding 2 every time, consistent, right? That means it's linear, all right. And if it's a graph, we can tell because it's a straight line, all right. Now, the majority of things we do in this class are going to be linear, okay. We don't learn how to graph nonlinear functions. We're going to do it today. We're going to recognize, right? But we're not actually going to learn, okay, about lots of nonlinear functions. So let's try an example here. Y equals 1/x. So is that y equals mx plus b form? Yes, right? So mx plus b. So it looks like the m is a half, right? And the b, if it's not written there, must be 0, okay? So if we want to do shortcuts to graph this, we would plot 0, we go up 1/2, we get our line. This wants us to fill in a table. So I'm just going to plug each of these x numbers in to my equation to determine what y is. So if I have 1/2 x, I'm going to do 1/2 times -4, okay? And then when I do that, I get -2. All right, and then I'm going to do 1/2 times -2. Gives me -1. 1/2 times 0. You can use a calculator for these if you need to. 1/2 times 2 gives me 1. 1/2 times 4 gives me 2. That's how I get the y values from my table. Then I want to plot those values on my grid. So 0, 0, over 2 up 1, over 4 up 2. I could draw my line now, but I'm going to keep plotting. So -2, -1 is left and down. Left 2, down 1. Left 4, down 2. I like plotting as many points as I can, all right, just because then I know, okay, whether or not I calculated these correctly. If I got a point that didn't fall on that line, I would know something's wrong. So because I'm able to connect those dots using a straight line, okay, is the function linear? The answer is yes. Okay, so how can I tell? I can tell by the fact that it's a straight line. I can tell by the fact that my values change constantly, right? +1, +1. Okay, and I can tell that my form is y equals mx plus b. There's 3 ways you can tell that it's a linear function. Let's try example 2. Y equals x squared plus 1. Is that mx plus b form? The answer is no. Okay, why not? Because it has x squared. It's not y equals mx squared plus b. It's y equals mx plus b. So the fact that I see this x squared should tell me that it's not linear. That's one way. Now I'm going to fill in my table, right? So same way, I'm going to plug these numbers in. So I have -2 squared plus 1 gives me 5. Use a calculator if you need to. -1 squared plus 1 gives me 2. 0 squared plus 1. Notice how I'm using parentheses to plug my numbers in. Gives me 1. 1 squared plus 1 gives me 2. And 2 squared plus 1 gives me 5. So notice how my table's not changing consistently, right? +1, +3, okay? That tells me it's not linear. So that's my second clue. And if I plot my points, okay, 0, 1, okay, -1, 2, 1, 2, 2, 5, and -2, 5. Excuse me. All right. So this is going to be hard to connect with a ruler, right? So when I draw my line, right, it makes a curve. Okay, it's not the best curve, but it's a curved line. It's not a straight line. All right, therefore, not a function, or excuse me, not a relation. Not linear, sorry. Non-linear, does not make a straight line. All right, so that's the way we're trying to determine these, okay? So if you want to pause and try the ones on the next page on your own, you certainly may, or you can just keep following along. All right, we're going to take a look at a couple others. Okay, so this is not mx plus b. Okay, if I plug these numbers in to my equation, all right, I would get -8, -1, 0, 1, and 8. Okay, so I'm plugging in the x numbers in to get the y numbers. So I'm not going to do them all, but -2 cubed gives me -8. All right, I'm going to plot those numbers here. So -2, -8. All right, -1, -1. 0, 0, 1, 1, 2, 8. Again, it looks like it could be close to a straight line, but it does turn out to have a curve in it. Okay, so this would be non-linear. All right, it's actually called a cubic because of the x cubed. All right, middle example here is linear, right? We have y equals mx plus b. Okay, so my m is 1.5, my b is 2. I can plug these numbers in, okay, to get the y values here. Okay, so let's see here. If I plug in, again, you're just doing 1.5 times -4 plus 2 is how we're doing that. Okay. So that should give me what? -4. Okay. Let's see here. -1, 2, 1, and well, no, that's not 1. Duh. Sorry. 5 and 8. Okay. So again, I'm looking at my table and noticing that it's increasing by 3 each time. So as long as they're going up by 3 every time, same number, it's going to be linear. All right, and then I plot my graph. So I'm going to plot each of those points and draw my line. So -4, -4, -2, -1. Kind of make a tough one to start counting by twos, but just do the best you can. 0, 2. Okay, 2, 5. I'm going to skip that one because it's in the between, right? And then 4, 8. And hopefully when I put all those points down and I draw my line, okay, I can connect them with a ruler, and that's another way that I know that this is linear. Now for my last one, oh, this looks funky. We have a fraction, which none of us really like, and the x is on the bottom. So pretty sure that's not mx plus b form, right? And if it looks funky, probably is. Okay, kind of a general rule of thumb. So again, I'm going to plug these numbers in. So like 12 divided by 1 is 12. 12 divided by 2 is 6, 4, 3, and 2. So I go, let's see here, 1, comma 12. And then I have 2, comma 6, 3, comma 4, right? 4, comma 3, and 6, 2. Okay, believe it or not, if I went all the way to 12, it'd be at 1. Okay. And this one's kind of funky here because 0, think about this, if I added 0 to my table, right, for x, what is 12 divided by 0? Right? That's special, isn't it? Undefined. You're going to get an error on your calculator, which means that this line doesn't actually ever touch, okay, the x-axis. Or excuse me, the y-axis. It never touches the x-axis either. All right, so this is actually a rational function. You probably got a little taste of these in 8th grade towards the end of the year. All right, it actually has what we call asymptotes, which are areas on the graph where the line never crosses. Okay, so usually we represent those with dotted lines. I'm getting way above where we're at in this class. Okay, but if I was teaching this in Algebra 2, I'd be drawing in vertical and horizontal asymptotes, which means a line it can get really close to that, but can't ever actually equal that. All right, but either way, all we're really out for is it linear? And the answer is no. Non-linear. Okay. Just a couple of examples. Again, we need to be really, really good at this. Graphing mx plus b, knowing what slope is, knowing what y-intercept is, all this. The other two, we just got to be able to identify. Is it a line? Is it not a straight line? All right, so down here, Todd noticed that both proportional and linear relationships form straight lines. Are they exactly the same? Are all linear relationships proportional? The answer is no. Okay, to be proportional, they have to go through 0, 0, but not every line goes through 0, 0. Look at this line up here. It doesn't go through 0, 0. It's not proportional. Okay. Here's 3 examples. Again, like I said, if it looks funny, probably is, right? The first one has an x squared, not linear. Okay. Second one, all right, plain x, linear. All right. And then third one, dividing by x, no, not linear. Okay. That's what we're looking for there, just trying to identify. Several students made a statement about the table. Okay, circle the name of the student who made a correct statement. Tabitha, right? Relationship is nonlinear because x increases, y decreases. I mean, she's right. X is going up, y is going down, but that's not what makes it nonlinear. Okay, that would just be any line with a negative slope. Okay, Arturo says relationship is nonlinear because x changes by a constant number and y does not. Okay, so now Arturo is onto something, right? Okay, because he noticed that the x's are going up by 2, which means the y should be going up by the same number every time, and they're not, right? This is going down 4, this is going down 12, right? This is going down 20, etc. So Arturo, he's got it. Luke, a graph of the relationship would not show a straight line. Again, he's right. He's smart enough to know if I plot these points, it's not going to make a straight line. So Luke is also correct. All right, so hopefully you copy those notes down, and we'll see you in class.